All right, here's problem 8, everybody's favorite thing, again, vectors. So let's talk about what the vectors mean again. Vectors just tell you about the x, y, and z coordinates of a line, and they're parameterized. So it's not too bad, really. What this is really saying is that your x coordinate, and here, oops, I thought I had my pen out. Your x coordinate is equal to 3 plus 2 lambda. And your y coordinate for the first line is equal to 2 minus 2 lambda. Your z coordinate for the first line is negative 1 plus 2 lambda. And so if you just plug in lambda equals 0, lambda equals 1, lambda equals 2, you can start to see how the x, y, and z coordinates move through 3 space. Similarly with the other line, so I guess I could call these x1, y1, z1. With the other line, I have the x coordinate is 2 plus 1 mu. I guess the 1 is redundant. The 2 y coordinate is 0 minus mu. And the z coordinate is 4 plus mu. Now, it says show that they do not intersect. And what it means for two lines to intersect is that they have the same x, y, and z coordinates. So let's just go through and start setting equal our x, y, and z coordinates and see what we can figure out. So I'm going to start with the x's. So we're going to take our line 1, 3 plus 2 lambda, equals our line 2, is the x coordinate, 2 plus mu. Can't solve it here because I have two unknowns, but I can subtract 2 from both sides, and then I would get 1 plus 2 lambda equals mu. And that's a nice substitution that I can use later. Now I'm going to set the y coordinates equal to each other. So the y coordinate from the first line is 2 minus 2 lambda, and the y coordinate from the second line is just negative mu. And there's a substitution. So I'm going to substitute on the right side of the equation. Mu is equal to 1 plus 2 lambda, so I have negative times 1 plus 2 lambda. Distribute the negative and you'll see why they don't intersect. 2 minus 2 lambda equals negative 1 minus 2 lambda. Add 2 lambda to both sides and you get 2 equals negative 1. What that's stating is that the only way these lines intersect is if 2 equals negative 1. Well, 2 does not equal negative 1, therefore the lines do not intersect. And there we go. That's the first part of it. Now, part B asks us to find the minimum distance between L1 and L2. And so we want to think about what the distance formula is and how we can minimize it. Okay, so I'm going to pause for a quick second here. All right, so one thing to think about here is what's the relationship between these two lines. And one thing I hope that you noticed is when I look at the vector that tells you the direction, you can think of this like the slope. Look at these two vectors. We've got one with a slope of 2, negative 2, 2, and the other one, 1, negative 1, 1. Because those are scaled values, like the top vector is twice as large as the bottom vector, that means that they are parallel lines. Each line is moving in the same direction. And when two lines are moving in the same direction, like this, and we try to find the minimum distance between them, what we can do is choose any point on line 1 and try to create a vector to another point on line 2 and then minimize the distance of that vector between them. So what I'm going to do for part B is choose my base point on the first line as 3, 2, negative 1. I can choose any point because the lines are parallel. So I'm just going to choose that one. And then the distance from that point to the other one and trying to find the vector is using that information right there. So let's write out vector AB. Let me give myself a little bit more space here. Let's get rid of you. Okay, so vector AB So if we go from A to B, where A is my 3, 2, negative 1, what do I notice? That the x value decreased by 1, 3 down to 2. The y value decreased by 2. the z value increased by 5 from -1 up to 4. And I also have the mu value that's walking 1, -1, and 1 right there. So that's my vector AB. What I'm trying to find is the distance here. And so the distance formula, the magnitude of vector AB, the distance formula is basically the x coordinate squared, the y coordinate squared, the z coordinate squared. And so we have -1 plus 1 mu squared plus -2 minus mu squared. And I'll squeeze it down here, plus 5 plus mu squared. Let's multiply all that business out. And so what do we have? Let's see, that's 1 minus 2 mu plus mu squared, then plus 4 mu plus mu squared, plus 25 plus 10 mu plus mu squared. So collecting my like terms, looks like we've got 3 mu squared. How many mu do we have? -2 plus 4 plus 10 makes 12. And then the constant 1 plus 4 plus 25 makes 30. So this right here is essentially our distance equation. And how do you find the minimum of something? You take the derivative and set it equal to 0. So I am going to clear the screen just so I can rewrite my distance and then take the derivative and set it equal to 0. So distance equals square root 3 mu squared plus 12 mu plus 30. Distance prime is 1/2 times all that junk to the -1/2 times the chain rule, 6 mu plus 12. And that's going to equal 0. When it equals 0, I can multiply both sides by 2, and I can multiply both sides by this, and all I have is 0 equals 6 mu plus 12, telling me that -12 is 6 mu, -2 is mu. So what is the minimum distance then? I resubstitute that into my distance formula right there and right there. So the distance equals the square root of 3 times -2 squared plus 12 times -2 plus 30. Let's see, so that makes 3 times, so -2 squared is 4, times 3 is 12, minus 24 is -12, plus that, I think we get square root of 18 as our minimum distance. And there you go. More fun with vectors.